Uniform electric field. We can create a uniform electric field by taking two parallel plates, one positive and one negative, and in between these two plates we will have a uniform electric field. Uniform means the electric field intensity will be same at all points. Uniform means same. So if I take two different points A and B, the electric field at point A will be equal to electric field at point B. So a few things to remember here. Positive plate is said to have higher potential, negative plate has lower potential. Magnitude and direction of electric field are the same at all points between the plates, and that's why we call it as uniform electric field. And we can also see that the electric field is pointing from the positive plate to the negative plate. Now in this video we want to discuss about Millikan's oil drop experiment, the formula which he used, not the exact experiment itself, but the formula which he used, and we will solve a problem based on it. So he actually used a uniform field, so that's why we just wanted to recap what's the meaning of uniform electric field. So we have got here two parallel plates which have a uniform electric field between them, and in between the plates there is an oil drop which is negatively charged, and obviously the oil drop will move down because of force of gravity. The earth is attracting it, but because it's negatively charged, it will also have a force of repulsion from the negative plate and force of attraction from the positive plate. So basically there will be, like, other than force of gravity, there will also be a force, a net electrostatic force which is trying to push it upwards, because negative plate pushes it up and positive plate is trying to attract it. So there will be an electrostatic force as well which is trying to push it upwards. Using this concept and applying the equations, saying that Fe is equal to Fg, we can derive a formula for the charge on the oil drop. So we are not going to go into the derivation of it, but we can actually derive it and get this formula Q equal to Fgd over delta V. In case if you are interested, we can have a quick look at it. Fe will be equal to Fg in equilibrium when the oil drop is having equal and opposite forces acting on it. Fe is actually Qe. It comes from the formula for electric field, which is F over Q. We can rearrange that as Eq or Qe, and Fg, you can just keep it as Fg, which is the weight of the oil drop. It depends on the mass of the oil drop. We want to write Q, so Q will become Fg over E. And electric field can also be written in terms of potential difference, which is, let me just show you the formula here, delta V equal to Ed. If you remember this formula we did when we did electric potential, we can rearrange this formula for electric field, which will be delta V over D, which if we write it here, delta V over D, this D will go up, and we can get the formula as Fgd over delta V. Now we are interested in the formula itself. If you want to derive it, we can go through these steps and see how it is being derived. In the formula itself, Q is the charge measured in coulombs, Fg is the weight or the force of gravity of the earth on the oil, which is the weight of the oil, which is measured in Newton. D is the distance between the plates, and delta V is the potential difference between the plates. Let's see how to solve a problem based on it. Now here in the picture we have got what is delta V, what is D, and It's also telling in the problem that the weight of the oil is 2.4 into 10 to the power negative 14. And is asking us to calculate what's the net charge on the oil drop. So we'll write the formula Q equal FGD over delta V. Fg, that's the weight. Fg is equal to 2.4 into 10 to the power of negative 14 Newton. We can write that here, 2.4 into 10 to the power of negative 14. The distance is 1.2 centimeter, which we have to convert into meters, so that will become 1.2 into 10 to the power negative 2. And delta V itself is 450 volts. We can write that 450 volts. We can then, that's an easy substitution. Just you have to remember the formula here. And I'm going to use my calculator to get the answer here. So let me just do that. So I get that as 6.4 into 10 to the power of negative 19, and because it's charge, the unit will be coulomb. Okay, let me just confirm the calculation once again. 2.4 into 10 to the power of negative 14 multiplied by 1.2 into 10 to the power of negative 2 divided by 450. That gives me 6.4 into 10 to the power negative 19. Now I would like you to solve this problem in your notebook and discuss any difficulties which you face in the class.